Hi, I'm Asadullah Shirzad. Today's video, I'm gonna teach you the new title of physics. That title is Transmission of Light Through a Parallel-Sided Transparent Medium. Okay, let's look at the parallel-sided transparent object. My student, this is called a parallel-sided transparent medium. Today we will study when the light is incident on the surface of this object, what happened? Okay, let me show you in the figure. This is, I draw the parallel-sided, it is parallel. It is one side, it is another. We can say parallel-sided transparent medium. Why we can say transparent medium? Because this object allow the light to pass through it. We can say this object is transparent object. And here we have, I draw for you parallel-sided transparent medium, and this object has thickness. The thickness of this object is T. When the light is incident on the surface of this object, it is reflected twice during its journey. You see, the angle of incidence is theta 1. When the light is incident on the surface of this object, it is reflected twice during its journey. The first refraction occurs when, you see, when the light enters the medium at angle theta 2. And the second diffraction occurs, you see the figure? The second diffraction occurs when the light leaves the medium and emerges with angle theta 3. This is called, theta 3 is called emerging angle. Okay, according to the law of refraction, you see that it is glass. Transparent medium is glass. Glass has refractive index. A refractive index of glass is N2. And it is air. Both sides of this glass is air. The refractive index of air is N1. Okay, according to the refraction law, or Snell's law, we have in first refraction, you see the first refraction, and we have the Snell's law for first refraction. Sine theta 1 over sine theta 2 is equal N2 over N1. I will find sine theta 2. Sine theta 2 is equal. We divided this one. N1 over N2 sine theta 1. Okay, and we have the rule of refraction for second refraction. When light, you see, the second refraction occurs when the light leaves the medium, and here we have emerging angle. Theta 3 is emerging angle. Okay, you know that it is theta 2. This angle also is theta 2. Theta 2. Okay, sine theta 2 over sine theta 3 is equal N1 over N2. Why? Because the glass in this refraction, the glass is first medium and the air is second medium. We write N1 over N2. And I will find sine theta 3 is equal N2 over N1 sine theta 2. I put instead of theta 2 this value. Sine theta is 2 is equal n1 over n2 times sine theta 1. I put this, and instead of sine theta do this value. Okay, sine theta 3. Sine theta 3 is equal n2 over n1, and instead of sine theta 2, I put this value, n1 over n2 times sine theta 1. We finish it this one, n1, n1, n2, n2. We finish this. Okay, now here we have sine theta 3 is equal to sine theta 1. We finish, we remove sine by sine. Now, theta 3 is equal to theta 1. This is a very important point. This point said that emerging angle and incident angle is equal. Okay, so we can conclude that the emerging ray, this is emerging ray, the emerging ray parallel to the incident ray. Let me write this. Okay, so we can conclude that emerging ray parallel to incident ray. You see the figure? This is very important. I proved that theta 3 is equal to theta 1. Emergent angle is equal to incident angle. So we can conclude that the emergent ray parallel to the incident ray. You see, incident ray and parallel is, they are parallel. Okay, but you see the figure, incident ray is I, incident ray, and it is emerging ray. They are parallel, but here we have amount of shift. You see, when light incident on the surface, it is refracted twice during its journey. It is refracted. It is emerging ray. It is emerging ray. It is emerging ray. You see the emerging ray is here. But light, we know that light propagates along a straight line. Here I draw a straight line. Here we have amount of shift. D is called amount of shift. When the light passes through the transparent medium, the light change its direction, and we have amount of shift. This amount of shift can be concluded. The amount of shift can be concluded. D is equal T times sine theta 1 minus theta 2 over cosine theta 2. This is the formula of N. This is the formula of amount of shift. We can find from this equation the amount of shift. You see amount of shift? This is the formula of amount of shift. What is T? Thickness. Theta 1 is incident angle, theta 2 is refraction angle. Okay, this equation says that, okay, what this equation says that amount of shift, this is the formula of amount of shift. Let me write. D is amount of shift. Amount of shift depends on three things. Be careful, remember. The amount of shift amount of shift depends on three things. A, thickness of transparent. Okay, thickness, just I will write thickness. You know thickness. This is the thickness of transparent medium or transparent objects. B, incidence angle. It means theta 1. C, refraction angle. The refraction angle is theta 2. Okay, this equation told us that amount of shift depends on three things. I told for you. Now let's do one more question about how to find amount of shift on parallel sided transparent medium. Okay, the question, let's do one example. The incident angle is 60. The refraction angle is 30. The thickness of parallel sided transparent medium is 6 centimeter. Find the amount of shift. We must find D. Find D. Let's solve this question. We have this formula. D is equal T time sine theta 1 minus theta 2 over cosine theta 2. We have this formula for finding amount of shift. D is equal, what is T thickness? Thickness is 6 centimeter times sine theta 1 60 minus theta 2 30 over cosine 30. Okay, D is equal 6 centimeter. 60 minus 30 is sine 30 over cosine 30. D is equal 6 centimeter. What is sine 30? You know, my students, what is sine 30? Sine 30 is 1 over 2. What is cosine 30? The root of 3 over 2. We finish 2 by 2 is equal 6 centimeter times 1 over the root of 3. Okay, D is equal, okay, we multiplied 60 centimeter. We divided, okay, we multiplied. Okay, here we also we can write this one. The root of 3. The root of 3 times 3. Okay, now 60 centimeter, the root of 3. Okay, the root of 3 times the root of 3 is 3. 1, 3, 2, 3 is 6. D is equal 2 times the root of 3 centimeter. Okay, this is the amount of shift. We find the amount of shift. The amount of shift is 2 times the root of 3 centimeter. Okay, guys, this is our today's lesson. Today we studied transformation of light through a parallel-sided transparent medium. Now, my students, if you have any question about today's lesson, try to comment below. And also, if you want to learn physics very easy, try to follow our YouTube channel and don't forget to subscribe our Afghan-Turk معارف schools. Okay, catch you later. Have a good time.